Hello. In this session we are going to talk about one particular system product that we have. We call it HSG, a hybrid shaft generator, and it has a particular way of working that we need to understand to be able to present it to our customers and to be able to sell it. It is a patented solution for Rolls-Royce, so we should be able to stand alone promoting this, even though competitors have similar close solutions. I think we have a good way of building a hybrid system, and we started first with this, so we have good experience back from 2009 with quite many vessels as we speak sailing with an HSG solution. So let's get on with it. So the topic is HSG, hybrid shaft generator. This is not just one particular component. It is a system consisting of several components that needs to work together to be able to have it work properly. So let me draw a hybrid system, and you should have had a look at one of the other sessions where we talk about hybrid electric and mechanic solutions, in order for you to understand why some will choose to have a hybrid solution. And when they have chosen the hybrid solution, then the HSG is really a good way of putting up a hybrid solution. It gives you added benefits that I will explain to you. A hybrid solution, as we have discussed in another session, have the diesel engine, the shaft, and the propeller, the gearbox, as a normal diesel mechanic solution. But when we say hybrid, then you have the possibility to run this transmission electrically as well. So then we draw a generator connected to the gearbox by a shaft. In a hybrid shaft generator solution, we will then have a frequency drive connected to a switchboard. Frequency drive, switchboard, and when this is then providing power for the propeller, it will as well provide power to the electric loads on the vessel. And in addition, we will have a genset as a typical hybrid solution. So there is nothing really special about this. This is something that you can do, and you will see in many hybrid solutions, a setup that can work mechanically. Diesel engine is driving the shaft and the propeller and the generator, producing power for propulsion and for the electric loads. So typical, a normal hybrid setup. However, I will tell you a bit about what are the different ways of utilizing our HSG setup in a way that makes the solution very special compared to other normal hybrid solutions. So let's say we can call this operational mode. Let's start with boost. So with a boost mode, the power from the engine is driving the propeller, but the engine may be 2 megawatt, the propeller is 3 megawatt, and the rest of the energy, 2 megawatt, is going in that direction, and 1 megawatt is coming from the small diesel engine and is going through the electric system and to the shaft as well. 1 megawatt. In fact, it's nothing very special with that solution either. This is something that has been done for many hybrid solutions to boost the propeller with an electric setup. And again, if you look at one of the other sessions where we explain the hybrid compared to the electric and mechanic, you will see why we would make a hybrid solution. Basically, you see parts of it here. You may choose a smaller diesel engine compared to the propeller design. So maybe you need the 3 megawatt only when you are pulling in bollard pull, let's say. So just a few percentage of your operational time, you really need all the 3 megawatt. And that's why you can install a 2 megawatt engine, because that's what you normally use, perhaps. And then you're more close to an optimum engine performance. And then you boost with some extra energy, with some extra power from the electric part, only the few hours that you really need everything on your propeller. Okay, so let's then put up another mode. Parallel. Then I'm going to draw the exact same picture once over. With the propeller, the generator, the frequency drive connected to the switchboard, and one or several generating sets connected to the switchboard. It is something you need to know about a shaft generator. And that is in a normal vessel setup, it is not possible to run the shaft generator in parallel with an auxiliary generator. You can do that for short time transfer of load, but not as a operational mode running in hours with the shaft generator running in parallel with the auxiliary generator. That has not been possible due to the fact that these two electrical machines they have to run at exact the same frequency. If you have a look at one of the other sessions again, you will see that the frequency is deciding the RPM of the electric machines. So these two machines has to have exactly the same frequency to be able to operate together into the switchboard. And due to the fact that this generator is connected to a big mechanical system that is a bit different in the regulation response than this auxiliary engine, it is almost impossible to keep this generator frequency as stable as this one, and then you will have trouble, disconnection of one of these if you run them in parallel. Maybe I should say for this boost mode that of course this electric machine is then working as a motor when you're driving a boost of the propeller. In this case, the electric machine is working as a generator, and you are in other applications with a typical shaft generator, you're totally dependent of having enough power from your shaft generator to cover the load that you need, or you have to disconnect the shaft generator and run only the auxiliary generator, because you cannot run them in parallel. However, with the HSG and this setup we have, it is possible to run this generator, shaft generator, in parallel with the auxiliary generator. So with that solution, this engine will provide power for the propeller, it will provide power, electric power, for the switchboard in parallel with electric power from the small auxiliary engine. And again, that function can give you new ideas when you put up how big engine, how big auxiliary engine, because now with this solution you suddenly can run them in parallel, and in situations where we really need a lot of electric power on board, you do not have to have a lot of auxiliary engines, because you cannot in normal situations run them in parallel with the shaft. But in this setup you can run them in parallel, and then suddenly you will have a lot of electric energy supporting your electric load in the network. So the HSG gives us the possibility to run in parallel with the shaft generator and the auxiliary generator. So that is one of the really good benefits from this as well. Okay, the next one, and again I will draw the same system but in another mode. Frequency drive, switchboard, and a genset. This one we can call electric. And in the electric operational mode, we can clutch out and stop the main engine, and we can provide all the power from the auxiliary engine and drive the propeller and provide electric energy to the switchboard. So that is as well something that is absolutely possible with existing solutions. With a hybrid setup you can do boost and you can do full electric as well. So really nothing new in that solution. That is normal in a hybrid, normal hybrid setup. You do not need a hybrid shaft generator to do exactly that. But that is one of the functions that you have when you have the hybrid shaft generator. And the last one is mechanical. And again, I will draw the complete system: gearbox, shaft, propeller, generator motor, frequency drive, switchboard, and auxiliary engine. And in the mechanical mode, this one is stopped, and all the power from the main engine is going to the propeller and providing electricity to the net, to the switchboard. Well, then you say, is it only the parallel part that is special? No, it isn't, because now I'm going to tell you something that is new for all the situations where the main engine is running. Because, again, back to one of the other sessions, you have heard me say that the switchboard needs a fixed frequency. So on board a vessel you will have typically 60 Hertz, and you need that frequency of the voltage to be stable for all the equipment connected to the electric network on board the complete vessel. You need a stable frequency of 60 Hertz. So in all these situations, you need 60 Hertz, 60 Hertz, and 60 Hertz. So the voltage frequency in all different operational modes always have to be 60 Hertz stable. And we have said that the frequency is dependent on the rotating machine, the electric rotating machine, and the RPM of that machine. There is a dependency between the RPM of the rotating machine and the electric frequency. So in a normal hybrid, you will have dependency from the switchboard to the main engine. The main engine has to go with fixed RPM to be able to deliver fixed frequency on the switchboard in all these different cases. However, with the HSG, that is not longer true. With the HSG, you can run your diesel engine at the optimum speed all the time. You're not dependent on the frequency of the switchboard. And that is why, because we have a frequency drive in between the generator and the switchboard. And again, back to one of the other sessions where we spoke about the active front-end technology. The active front-end technology gives you the opportunity to let your energy flow in both directions through the frequency drive. That's why you can see in this operational mode, the power is flowing through the frequency drive in that direction. The same with this one, the power is flowing in that direction through the frequency drive. But over here, the power is flowing in that direction. The power is flowing in that direction through the same frequency drive. This is not possible with a 12 pulse, 6 pulse, 24 pulse solution. You need an active front end inside here. And when you have a frequency converter converting the frequency between the generator and the switchboard, in all these cases, you are suddenly not dependent on the frequency on the switchboard on the main engine. Now, in this case, you may have a motor and you don't have to, an engine, you don't need to pick an engine prepared for 50 or 60 hertz. You could in fact have 1200 or let's say an 1800 RPM high-speed engine, and you can let it run at 2000 RPM if the engine maker allows that. And suddenly you can have more power out of the same engine. And you can install an engine running at 2000 RPM at MCR, max continuous rating, and you can freely adjust the RPM of the main engine dependent on how much load do you require at this end. And then you will save losses on the propeller side because you're able to regulate the RPM of the complete engine and propeller shaft line system. Due to the fact that the frequency drive inside here gives you 60 Hertz on the switchboard, stable all the time, independent of the RPM of the generator. So suddenly you have a setup where you can adjust the RPM of the main engine in boost as well as in parallel as well as in mechanical mode. You have probably the best utilization of that function with you have in the mechanical mode, because suddenly you can run your vessel, you can sail your vessel at lower speed without going into the electric mode. If you are at really low load situation, sailing really slow, you need very few RPMs on the propeller, well, then it's very wise to go for the electric operational mode. Because with this mode, you're able to go all the way down to 0 RPM on the propeller. With this one, you're not able to go down to 0 RPM on the propeller because the engine is running and you cannot go below idling. But as I said, for a typical hybrid setup, this would be running at nominal speed all the time. So with a normal hybrid setup, this will be running at whatever the rating is for the engine and the rating for the propeller. Let's say 180 RPM on the propeller. However, with this frequency drive HSG setup, we give the system the possibility to take down the RPM from the maximum RPM and all the way down to idling. Still making 60 Hz stable frequency on the switchboard, because we have this active front-end frequency drive in between. So by this solution you will have a more optimum utilization of the engine and a more optimum utilization of the propeller in conditions where you do not need absolutely full maximum power. So I would advise you, if you would like to have a further look into the savings on the engine because you're able to reduce the RPM, I believe our friends in Bergen Engines will provide you with some graphs and diagrams of the engines, and you will easily see that when you reduce load and you are able, because of this, to reduce RPM as well, then suddenly your fuel consumption is much better for the engine. And you keep as well the combustion temperature higher, so your combustion is cleaner, it's more efficient, and you have higher temperature in your exhaust. So if you have a cleaning system in the exhaust, it will work better in low load situations, because this gives you the opportunity to reduce the RPM. And I believe as well our friends in propulsion can easily give you a graph, a diagram of a propeller, and you will easily see when you do not utilize all the 3 megawatt in this case, when you not utilize the full maximum power, then you will save a lot of energy by taking down the RPM. So the hybrid shaft generator really introduce an opportunity for the system on board the vessel to save fuel based on saving losses on the propeller side and saving on the engine side. Better utilization of the engine installed, better utilization of the propeller installed in low load conditions. So let's say, just as an example, a fishing vessel. A fishing vessel is sailing from shore and out to the fishing field. The vessel is empty, they are not in a hurry, they will easily sail just diesel electric. They do not need to start up the big engine, just one or maybe two small gensets, providing them enough energy, enough power to move this vessel from shore out to the field as efficient as possible. At once you are out on the fishing field, you start searching. It's still wise to use this solution to look for the fish. Maybe it's almost standby and idling in the sea. Then you are starting to throw your net into the water, and you are catching fish, and you need a lot of power to be able to pull the net. Maybe it's windy, it's waves. You need a lot of power to really pull a net full of the catch. Okay, so when we start fishing, then we go for the boost mode. We start up the big engine, we connect the auxiliary engine and give you really the maximum power that you need. For those few hours, you really work with the catch, you're pulling the net, and you are bringing the catch over and into the vessel. Then you have the parallel mode, and that you can do. Let's say this fishing vessel has a factory on board, refrigerators, and you need a lot of electric energy for the factory and at least to freeze the fish. So by this solution you can start sailing on your way back home. You need a lot of energy, maybe during the factory situation, during starting up your refrigerators and freezing the fish, stuff like that. Then you can in fact run the engine at variable speed based on how much propeller and electric power you need. You will regulate this automatically based on the need for power, and you can do it in parallel with one or two auxiliary engines when you need a lot of electric power. And then you have a long sailing distance back home. You have a vessel that is heavy loaded with a lot of fish. Well, the most efficient way to sail is then to start the big engine, let all the rotating power go through a shaft line to the propeller. You have the possibility to regulate the RPM on the engine to find the optimum combination of propeller pitch and speed. This is done automatically in our automation and control system. However, we find the optimum RPM, you're sailing back home, fuel saving, as efficient as possible, because you're able to reduce the RPM to the optimum point and still provide electricity to your switchboard, and no need to start auxiliary engine. That of course would have increased the fuel consumption and the maintenance and stuff of running hours on this engine. So the HSG is a system very well suited for hybrid vessels, where you have different ways of operating. You need really all your power just for some hours, at least of a little percentage of your operational time, and you have the possibility to produce the electricity in parallel. You can go full mechanic with low RPM, and you can go full electric with the RPM all the way down to zero. You save maintenance, you save noise and vibration. You know, just by reducing the RPM of the main engine in all these situations, you can reduce the RPM of the main engine. You save fuel, less vibrations, less noise, So you have several benefits from the possibility to reduce RPM on the main engine. So it's really about RPM. It's really about finding the optimum RPM of the main engine and the propeller, because on the propeller side you have the biggest losses, but everything contributes to an optimum energy efficient system on board the vessel. And to have those 4 operational modes, it's not a very difficult setup to have on board. It's quite easy for the captain to pick and choose which operational mode are we going to use in this particular situation with the vessel. So that was a quick and short introduction to the HSG solution. And as I said, this is not only putting a frequency drive into the system. It has to be an active front-end drive. You need to have an electric machine that is capable of both being generator and motor. It's not a standard normal generator. We normally use induction machines for this. And again, the switchboard needs to be special made, prepared for this function, due to the fact that we have short circuit levels inside here that has to be handled in a different way due to the setup with frequency drive providing fixed frequency and stable voltage into this switchboard. And that's why this is a system, and it has to work together with the pitch control, the RPM control, and everything has to be together in an automation and control system to have this work in a proper way. That's why this is not about selling just an HSG drive. This is a system that is connected together, and it is dependent of us in Rolls-Royce have full control of the switchboard, frequency drive, the generator motor, and the control system, so the propeller and the engine as well, to be able to maximize this efficient system. So HSG is not a component, it is a system that gives a lot of added benefits for a ship owner. So please go out and talk to them and tell them what is possible with our system. Hope that was useful for you. Thank you.